Okay, today I want to teach you how to read a position versus time graph. And this is actually super important because you'll be seeing these a lot, um, as well as velocity versus time graphs. But I'm going to do velocity versus time graphs in a separate video. So for position versus time graphs, I want you to start by thinking of the equation, which is just y equals mx plus b. And as I write this, instead of y, I'm going to put x. And x is position. Now, you might be thinking that it's really irritating that it's x, but it's on the y-axis. And the reason for that is in another couple of units, we're going to be doing projectile motion where we have objects that are moving both in the x direction and in the y direction at the same time. And so x really means that it's moving in the x direction, but motion is still going to be graphed on that y-axis. And then on my x-axis, instead of x, we are going to have time, and time is just t. Instead of m, we are going to have our slope. And slope, if you remember, is rise over run. And in this case, my rise is how much it has gone up. So if it was here at this moment in time, and then later on it's up here, it's going to have traveled a certain amount of distance. And if I put numbers to this, it usually helps when I'm explaining. So let's say this goes from 5 to 12, then that is how much my position has changed. That's my rise. So that then is going to be my change in position. And I'm going to divide that by my run. And in the same thing, I'm going to come down here. Well, it started at time of 0 seconds. Let's say it ended at a time of 10 seconds. Then this is how much time happened during that section of the graph between here and there. And so that is how much my time has changed. So this is going to be my change in time. And what you need to know here is that change in position divided by change in time, that's the definition of velocity. So that means your slope is the velocity. And so I'm going to come over here and I'm going to add velocity as my slope. And then I go plus my y-intercept. Well, at 0 seconds, I come up and this is where it's at. That is where it is at 0 seconds. So that is my starting position. And the starting position isn't always where it was at 0 seconds, but I like to think of it that way when I'm introducing it because then the little zero makes a lot more sense. You could also put x sub I for like your initial starting position, and that would be fine as well. I won't mark it wrong. All right, so far we know that where the object is at is going to be on this line. So if I wanted to look up where something was, I could go to like 7 seconds and follow it up. And then once I get here, just go over and then look at where it's at. And I just taught you that the slope of the line is your velocity. And the last thing that we talked about, but I didn't directly say, is that if I want to know how far something went on a position versus time graph, I'm just looking at where it was and where it is now. And so that's this distance here. That's your change in position. And so when we subtract these two from each other and we subtract 12 minus 5, then that is my change in position. So my change in position for this particular example is the change in the vertical direction, which is just 12 minus 5, which is 7. So far we've talked about on a position versus time graph that the slope is the velocity, the y-intercept is your starting position, and the change in height is your change in position, or where you started compared to where you end. So at 0 seconds, it was, let's say 5 meters. And a little bit while later, at 2 seconds, it was still at 5 meters because I go up and follow it over, and that's where it's at. And if I keep looking, it's the same place the whole time. So this means that this object is not moving and it is at a position of 5 meters. Cool. Next. If I want to compare these two graphs, and I remember that velocity is our slope, then that means the purple line is going faster and the blue line is going slower, because the purple line has a steeper slope and the blue line has a less steep slope. But they're both starting at the same position because they both are at 0, 0 at the beginning. And on this second to last example, I want to compare these two. So we're going to compare the blue one, we're going to call that B, and we're going to call the red one R. And so we want to know which one is going faster, which one's farther ahead. Um, and if I look at these, I can tell you that B was going faster. Well, why do I know that B is faster? Well, I know that B is faster because of the slope. So the steeper the slope is, the faster it's going to go. And it's going to be faster the whole time because the slope is steeper the whole time. Well, then what's up with R? Well, I can tell you that R started farther ahead. So I know R started farther ahead because it has a positive y-intercept, because that's right here. And I know that B started at 0. And I know B started at 0 because it goes to the origin. So then the question is, which one went farther at 10 seconds? So if this is 10 seconds, which one is farther? Well, the answer is B. And B went farther for two reasons. Can you think of both? Well, there's two reasons B went farther. The first is that it went faster. And if you travel the same amount of time and you are going faster, then you'll go farther. And the second reason is because if I look at where it started right here. If I look at where it ended here. Compared to R, that started at 0 and only went a little less than halfway up. So that means B went a little more than twice as far. So there's why B went farther. So what does it mean when you have a slope that's negative? Like this graph is going down. Well, that just means that you started up here at some positive position, let's call it 20 meters, and then you went, and over time, you went closer and closer to where 0 is. Maybe you were walking backwards. Maybe you started at the finish line and you walked back towards the starting line. Either way, this is an indication that it was going backwards or going back towards where you said 0 was, from a positive position towards 0. So this then is a negative velocity because it has a negative slope. And that's it.